what we are going to do is going to run 4 to 5 tests, which will tell us all the things we need to know and do about analyzing our data. Okay. Of the data, we use a tool called Run Chart. It is available in Minitab. Now, the important thing here is the reason we use Minitab is because it is very easy to use, and I want to concentrate more on the test and rather on the software, because Minitab will easily give you the results. Okay, so let's look at how do we calculate our stability in terms of Minitab. So go to the Sigmaway tools and template. You can go to the sales data. You can go to the sales data and you can pick up this period and revenue data if you want to. Let's pick this up. Okay, you've got this data, and then we go to Minitab. We open a new worksheet and I paste these cells, and within Minitab you go into Stat, Quality Tools, Run Chart. Now in this, in the single column, we are going to be putting revenue, the numbers. The single column option, you need to put in the numbers. Now in the subgroup side, what really happens is sometimes you have subgroups in the data. They're not patterns, but they're because of subgroups. Let's say you've got data mixed up because one is from the evening shift, one is from the morning shift. So in case you've got a label which specifies, let's say there's a third column in the data which specifies that this is from morning and this is from evening, then you will put the label there. Okay, the subgroup size, else you will put 1 and then we'll press OK, and here we go. So this is the run chart. Now when you look at the run chart, you will see that at the bottom of the run chart there are quite a few values. A run is described as movement of data points in one direction only without changing. Okay, so if it is going up, it will keep going up. If it is going down, it will keep going down or remain stable. That is described as a run. It will not change direction. Okay, so number of runs refers to how many times does it change direction. Okay, now there are two things. The dotted line you see here in the graph is the median. So the first thing you see about is the number of runs about the median. It talks about how many times does the data go up and down around the median, and it says 8 times. Okay, it says 8 times. Right next to it says number of runs up and down. So this number of runs up and down does not care about the median. All it says is how many times does the data change direction. It says 18 times. Okay, now based on the kind of data, what is the expected number of runs? This kind of a data, it should be 19. In this case, it is only 8, and expected number of runs without median should be 23.7. In this case, it is 18. Okay. Now there are 4 kinds of patterns you search for. In any run chart, there are 4 kinds of patterns you search for. They are called clustering, mixtures, trends, and oscillations. Clustering, mixtures, trends, and oscillations. Okay. All 4 of them have got p-values given in the run chart. You will look at this p-value and compare it to 0.05. Okay, which is the alpha. You'll compare it to 0.05. If it is less than 0.05, then that particular pattern is present. If it is greater than 0.05, then that pattern is not present. Now if you look at these patterns, clustering and mixtures are on the left hand side and trends and oscillations are on the right hand side. So clusters plus mixtures will always add up to 1. They are mutually exclusive, or rather they will always add up to 1. So if you have issues with clustering, you will not have issues with mixtures. If you have issues with mixtures, you will not have issues with clustering. Similarly, trends and oscillations will always add up to 1. Okay, it does not mean that you will have issues with either of them. It's quite possible that everything is greater than zero point 0.5 and you've not 0.05 and you've got issues with none of them. That is very much possible, and that's usually the norm. But whenever you add the two numbers, you will get 1. So let's look at it here. We see the value of 0 for clustering. So it's less than 0.05, we have an issue with clustering. We have a value of 1 for mixtures. It's greater than 0.05, way greater. We have no issues with mixtures. We have a value of 0.001011 with trends, which is less than 0.05. We have an issue with trends. We have a value of 0.989 with oscillation, which is much higher than 0.05. We have no issues with oscillations. So based on this run chart, we see that given this particular data, we have an issue with clustering and trends. Trends mean that something is going continuously in one direction. And you can see towards the end, from point number 25 onwards, there are quite a few points going upwards and not coming down. So naturally, even without understanding the statistical significance or method of calculating a trend, looking at the data from point 25 to 35, you would say, yes, there is a trend happening here. Okay. So this is how we look at a run chart and look at the different values of P to figure out the different kind of patterns and issues we might have with run chart. So now we come to the second part of analyzing the data. We use the run chart to ask for the stability. In the run charts, if you've got any of the 4 issues with clusters, mixtures, trends or oscillations, your data is not stable. What it says is that there are certain patterns in your data which are not caused by common cause variation. So this is not just because of the process, there's some special cause variation. So you need to find out what that special cause variation is, remove those data points and then run the run chart again so that none of the p values are less than 0.05. Post that, we come to the next stage, which is about studying the shape. Shape is all about figuring out whether your data is normal or non-normal. Okay, remember, like I said before, either your data is normal or it's non-normal, never abnormal. We'll use the same data, I guess, to look at and study the shape. Let's look at the students and marks data. Kindly open the minitab data.xls sheet. So as you can see, we have the student, we have the data for the central and normality. So we'll be looking at this right now. And then we have the data for the run chart as well. So let's look at the central and normality data. And we pick up this data which says student and marks, copy it, and paste it in Minitab. Like I said before, when you're pasting data along with headers, make sure the headers are entering the gray cells. So now we want to look at the shape. So for shape, what you need to do is you use my favorite tool, go into basic statistics, and go into graphical summary and choose marks. Once you choose marks, you'll get a graphical summary and you will get quite a lot of data in terms of statistical description regarding the dataset marks. Like I mentioned before, you look at standard deviation, mean, skewness, kurtosis. But what we're looking at is the Anderson-Darling normality test. We need to look on top as the Anderson-Darling normality test and look at the p-value. The p-value is 0.233. Whenever we create a null hypothesis, we say that things are as they should be. In terms of normality test, we say data is normal. Okay, that is a null hypothesis. And our alternative hypothesis is that data is not normal. Okay, so in this case, since the p-value is greater than 0.05, that is 0.23 is greater than 0.05, we fail to reject our null hypothesis and we move forward with the thought process that yes, that our data is normal on this data set. If we apply further statistical testing, we can use the testing which is used for normal data sets. So there are different kinds of data. You've got normal data, you've got skewed data, long tail data, bimodal data. Okay, so when you're trying to look at the centering and spread, centering as defined by central tendency, spread defined by variance. So the shape of the data matters a lot. That is why we studied the shape of the data before we move into centering and spread. Okay. So if your data is normal, you can use the mean for central tendency and standard deviation for spread. If your data is skewed, either left skewed or right skewed, so bulk of your data is either on the left hand side or the right hand side, then you can either use the first quartile or the third quartile for the central tendency and stability factor for the variance. Stability factor is calculated as Q1 divided by Q3. Q1 divided by Q3 is the stability factor. And nearer Q1 divided by Q3 is to 1, more stable your data. So nearer the value is to 1, more stable your data. Okay. In case your data is long-tailed, okay, your data is long-tailed, in that case, you will use median as your central tendency and span or range as your variance. So range, as we talked about it before, is calculated maximum minus minimum. How is span calculated? What happens is, in a lot of times, your data set has got extreme values, and span is a measurement to calculate variance by ignoring those extreme values. So let's say you want to calculate a span, and in that way you want to calculate a span and call it span 90. Span 90 means that you will only be taking into account 90% of the data points. So if there are 100 data points, you will only be taking into account 90% of the data points. So 90 data points is what you will be taking into account. Now, how do you remove the 10 data points? You divide the 10 data points into two parts. You remove the 5 largest data points and the 5 smallest data points, and then you calculate the range. That is the leftover maximum minus minimum of the 90 data points. That's how you calculate span 90. Okay. So if your data has a central tendency for mean, if your data is long tail, then you would use median as a central tendency, and variance you could use span or range. Now there's another shape below which you see, it's called bimodal. So bimodal shapes actually tell you that your data is a mixture. It could be from two different processes. So you need to separate out the data. It's possible that the data is mixed in from evening shift and morning shifts. It's possible that the data is shipped from two regional headquarters. So you separate out the data, and the chances are that the bimodal data will convert into a normal data, and then you can use the mean and standard deviation for calculating the central tendency and the variance. Okay. If you look at the shape of the graphs which you get in the graphical summary, there is also a test called the normality plot. So if you look at the graphical summary along with the normality plot, which you can run in Minitab, using these two shapes, either of them, you can figure out what kind of a central tendency or variance is recommended for using. Okay, so let's look at the normality test. Okay, we are going to look at the normality test. Even though you can get the normality out from using the graphical summary test, we can also use the normality test to figure out the normality. So let's look at that. How we'll go about it is, we'll use the same data, student and marks. If you go into stat, basic statistics, and let's see, do we have a normality test here? If you go down, you'll see a normality test. In the normality test, choose marks again. For test for normality, use Anderson-Darling as the default and press OK. Okay. And now again here, if you look at it, this is a different kind of a graph which talks about your normality test, and your p-value comes at same p-value 0.233, which is greater than 0.05, and you'll move forward with the assumption that your data is normal. Okay. So you can either use the graphical summary test or the normality test to find the p-value from the Anderson-Darling and move forward. Okay, so this is how you move forward with the normality. Like I mentioned before, you've got different kinds of data distributions and you've got the normality plots. So this is roughly a normal distribution. This is a bimodal distribution. Like I said before, you can divide it into two parts and you probably would get two normal distributions. This is an exponential distribution. This is a long-tailed distribution, which is data measured versus a target, where you will probably use median as a central tendency. And this is what each of these normality plots look like. So you can look at both of these to decide the shape of your data, or you can just look at the p-values and figure out whether your data is normal or non-normal. Data is often, but not always, normal. A normality testing helps you determine if it is normal and gives you insight into how your process is behaving. When it is not normal, it may be because of more than one underlying process. So it might be because of a bimodal issue. Caution is needing in proceeding. If it is not, consult your BB or MBB. So if it is a non-normal data, contact your black belt or master black belt to figure out which are the right statistical testing methods you should be using to look at your data. Okay. So once we have baselined our output distribution, you must do a normality test to see if the data is normal. The results of a normality test are key deliverable for a project. When you encounter non-normal data, let's get some guidance from a black belt or master black belt. Okay. And the first thing you need to check before you classify it as non-normal is if it is bimodal. If there are two kinds of data being mixed, so you might try and segregate it and then move forward. If you do not have more than one process in the data set, then based on the guidance, you must choose the appropriate statistical test for non-normal data. There are quite a few available. Okay.